All right, welcome to online lecture 3. Today we're going to talk a little bit about some variable basics, and then we'll get into descriptive statistics proper. So let's go ahead and get going. Okay, so there's two branches of statistics. And we kind of alluded to this a little bit before, but there's descriptive statistics, where we use that to summarize and describe a group of numbers from a research study. So with descriptive, again, you're just trying to summarize, just trying to describe. Okay. Inferential statistics is kind of what we've been talking about. It's the procedure for drawing conclusions based on the scores collected in a research study, but going beyond them. In other words, inferential statistics is this idea that we collect a sample and then compute some statistics on that sample and then draw conclusions about the population. Okay, that's the big difference there. In inferential statistics, we're collecting a sample and drawing conclusions about the population. All right. So, as we kind of mentioned before, if we only collected population level data, we could just run descriptive statistics and call it a day. It's only because in the behavioral sciences, we're often forced to go ahead and pull a sample because we don't have access to the whole population that inferential statistics comes into play. All right. So now, as promised, let's talk about some basic concepts, some basic information about variables. So let's start with some definitions. Variable is a characteristic or condition that can have different values. Anything that can take on different values is a variable. So sex, race, birth order, temperature, level of stress, right? These are all different variables because they can all take on multiple values. Values are the actual numbers or categories that a variable can have. So for example, with birth order, we can talk about being born first or second or third or fifth or eighth. With temperature, we might want to talk about the idea that it is around 85 degrees today, or that it's 20 degrees today. And level of stress, let's say we had a scale where we were measuring level of stress from 0 to 10. Those would be the values. Okay. Data are measurements or observations of a variable. It's what you're collecting, right? It's what you're collecting, the information that you're gathering regarding a particular measurement or study. So if I collected information about people's bowling scores and the information was 100 for person 1 and 200 for person 2 and 250 for person 3, etc., that would be my data. The 100, the 200, and the 250 would be my data. And if I happen to only get a single measurement or observation, that's just called datum. Okay, that doesn't come up very much in this course, but I thought I'd share it with you. Okay. So now that we have a sense for what variables are, I want to talk about kinds of variables with you. The first kind of variable is called nominal or qualitative. It's a variable that has values that are names or categories and has no natural order. So things like gender, race, ethnicity, political party, eye color are all nominal variables. And why is that? Because in all of those cases, when you look at the values, their names or categories. There's no natural order. So let's just take eye color for an example, right? Some people might have blue eye color or green or brown or hazel or black or what have you. How would we order those? We can't really, right? It doesn't really, there's no natural order there. We can impose an order. We could say, oh, I'll order them alphabetically. But there's no natural order to these values. Whereas on the other hand, we have numeric or quantitative variables. These are variables that have values that are numbers. And generally we can order these. So in this case, we're talking about things like birth order or order finishing a race or temperature in Fahrenheit or stress ratings or height or length. Okay, these would all be numeric or quantitative variables. Okay, so kinds of variables is useful. It gives us one nice division between two major kinds of variables. So that's good. But we need to take this a step further and talk about levels of measurement. Okay, and that's going to be really helpful because different levels of measurement call for different types of statistics. So here's what we're going to do. We're going to leave nominal alone. Okay, we like that the way it is. No problem. That's going to stay its own category. But we're going to go ahead and take numeric or quantitative and divide that further, because that's such a broad category. We're going to divide that further into 3 other categories. So let's do that. This is level of measurement. Now, you can use the mnemonic, no oil in rivers, to help you remember the different levels of measurement, which are nominal, ordinal or rank order, interval, and ratio. Okay. So let's start with nominal. This is a variable in which the values are categories with no natural order. Like we already talked about, right? Gender, religion, ethnicity, political party, eye color, all of these are nominal variables. So that's the same as what we had on the previous slide, no changes. Next, now we're going to talk about all these quantitative or numeric variables that we're breaking down into 3 other categories. So the first of these 3 categories is ordinal or rank order. This is a numeric variable in which values correspond to the relative position of things being measured. Class standing, you're first in your class, you're 50th, you're 100th. Birth order, you're first, you're second, you're third. Or position in a race, you're first, or 100th, or 1000th. So here's the thing about ordinal level of measurement. It's useful, but it doesn't tell you about the relationship between the different positions. Let me give you an example. We're talking about a race now, okay? So we're going to talk about this race, and one person comes in first, one person comes in second, and another person comes in third. Does that tell you how close these people were when they were racing? It really doesn't. Because let's say the first person came in 2 minutes. Second person came in 2 minutes and 2 seconds. Third person came in 6 minutes. You see, there's a lot more distance between 1 and 2, and number 3 is way out there at 6 minutes. 1 and 2 are pretty tight, but 2 and 3 are pretty far apart. And just knowing that they're first, second, and third in the race doesn't tell you that. So let's now talk about the next type, the next level of measurement, which does tell you that. and that's interval or equal interval. This is a numeric variable in which differences between values correspond to differences in the underlying thing being measured. Now I'm going to skip this next sentence. I'm going to read it to you, but we're going to come back to what it means in a minute. And that is 0 does not mean absence of the thing being measured. We're going to come back to that. So for now, let's just understand this as things like temperature. The difference between 50 degrees and 60 degrees Fahrenheit is the same as the difference between 60 degrees and 70 degrees Fahrenheit. Or presumably, ratings of mood. If you have people complete a mood scale measured from 1 to 10, you would hope that the difference between 1 and 2 is the same as the difference between 7 and 8. Now, some people would argue against that, but we're not going to worry about that for this class. But if you're thinking something different about that, that maybe it could fall into a different category, you're probably on the right track. But we can talk about that during our question sessions. Okay, so temperature, ratings of mood. Now let's move on to ratio. Ratio is the same as interval, except 0 means the absence of the thing being measured. So what do we mean by that? Runners' times in race. See, in that case, when you're looking at time, 0 means the absence of time. Weights of 4th graders. Now we're looking at weight. 0 means the absence of weight. Now let's go back to interval just to make sure we understand this. With temperature, does 0 degrees Fahrenheit mean the absence of temperature? No, it really doesn't. It's quite cold outside, but it doesn't mean the absence of temperature. And on a scale that goes from 0 to 10, looking at ratings of mood, would 0 mean the absence of mood? Probably not. Right? It's probably going to mean something like a very poor mood if this was a scale from poor to a really good mood. So only when it's the absence of something do we call it ratio. Only when 0 means the absence of the thing being measured do we call it ratio. Otherwise, it's interval. Okay. Let me click back in here so we can move on. All right, so now let's kind of pull this together. So I'm going to give you a setup of a situation, and I'm going to ask that you take a pause in this video just to answer the questions so that we can make sure we're all on the same page. So you are conducting a study to evaluate how happy students are with their living arrangements. For this study, you asked 200 Westchester University College students to rate their level of happiness on a scale of 1 to 100. Now you see there's 5 questions below. About sample, what's the sample, what's the population, what's the variable of interest, what's the type of variable, and what's the level of measurement, and what are the possible values. So again, please go ahead, take a quick pause, answer these questions, and I'll be back to answer them for you in just a second. Okay, so let's answer these questions. What's the sample and population? Your sample, remember, is who you actually have in your study. So in this case, that's 200 Westchester University College students. That's who's in your study. What's your population? Well, hopefully we chose the sample at random. We use one of our nice random sampling techniques. And so our population that we're hoping to generalize to is most likely Westchester University College students. Now let's say that you were thinking it would be all college students. Let me explain why that's not the case. Don't you think all college students might have different opinions when they're talking about how happy they are with their living arrangements? Don't you think there might be differences across different colleges? I think there could be. And you didn't collect information about all colleges, just about Westchester University. So you can only hope to generalize to Westchester University college students. What's the variable of interest? What are we measuring here? Its level of happiness. How about the type of variable? The type of variable, well, it looks numeric to me. We're measuring things on the scale from 1 to 100. That looks pretty numeric. Okay, now we come to level of measurement. No oil in rivers, right? So we can eliminate nominal because this is a numeric type variable. And it's a scale rating. Scale ratings are almost always interval. It's not ordinal because we don't really have that first, second, third thing going on. And it's not ratio because 0 wouldn't mean the absence of happiness. And in fact, we don't even have a 0 as an option here. So it's interval. What are the possible values? 1 to 100. Those are all the possible values that a student can rate their level of happiness. Okay. So now let's press on into measures of central tendency. We're formally getting into our descriptive statistics a little more, and we're going to talk about central tendency. Now, central tendency is where we use a single number to describe a group of scores. It defines the central point of the distribution. However, different ways of measuring the central point exist, and the central point is defined differently for each measure of central tendency. Now, the measures of central tendency we're going to discuss are the mean, median, and mode. Okay, so some of you are thinking, I know the mean, median, and mode, and that's great if you do. I still ask that you make sure to watch this section because we're going to talk about this rounding rule that is specific to this class. So maybe you get to kind of relax a little bit during this section. All right. Let's start with the mean. It's the average value. It's the sum of all values divided by the total number of values. Now, the mathematical formula for calculating the mean is either x bar or m. That's the symbol for the mean. And I'll tell you right now, we're talking about sample means here. Now, I tend to use x bar a lot more than m, but they both work. They both would be symbols for the mean. Okay, so what does it equal? It equals this weird thing on the right. Let's break this down. The odd E-looking thing is actually a summation sign, and it means to add up all of the values following this symbol. X are the values for the variable, and N is the total number of values. So for example, let's say we had the numbers 2, 3, and 4. Well, the summation sign is telling us let's add up all our values. What are our values? 2, 3, and 4. Excuse me. So we would take 2 plus 3 plus 4, we'd get 9. We divide by the number of actual values, which is 3, and we would get 3. Excuse me. Let's go through an example of figuring the mean. If the scores for a particular study were 10, 5, 9, 8, 6, 5, 9, 8, 7, 6, 5, 6, how would we get the mean? First, we have to figure out how many numbers we have, which if you count them out, they're 12. Next, we would go ahead and add up all those numbers, at which point you would get 84 divided by 12, and you would get 7.0. Now, if you're wondering why is it 7.0, we'll discuss that in just a moment. As opposed to just 7, right? Why do we add that 0.0? Okay, so here is our rounding rule for statistical calculations. This is just a rounding rule that we're going to use for this class. May not be the same as rounding rules that you would use for other classes. Okay, but it's what we're going to use here just to make sure we're all answering the same way. So you're going to state your answers with one more decimal place of precision than is found in the raw data. Okay, what does that mean? So the mean of 2, 3, and 5 is, okay, we know how to do this. We add up 2 and 3, which is 5, 5 and 5, which is 10. We divide by 3, and we get 3.3333333 repeating. What are we going to round that to? Well, let's observe that our original data, 2, 3, and 5, had no decimal places, right? It wasn't 2.0, it wasn't 2.1, it was just 2. No decimal places. So our final answer is going to have one more than that, which is 1 decimal place. Excuse me, which is 3.3. So we'll get to do some more examples using this as well. Okay. So again, we've added up 2, 3, and 5 to get 10. We've divided by 3. We get 3.3333 repeating. And because 2, 3, and 5 have no decimals, we add 1 to that, and we'll get 3.3. Okay, so because the raw data are whole numbers, we round to the nearest tenth, and we're only going to round our final answer. Now, this is a trivial concept for right now because we only are doing simple operations. But when we move on to something that's a little more advanced, you'll find that it's actually helpful to know that you're only rounding the final answer. Okay. Okay. So with that being said, let's talk a little bit more about the mean. For a population, the symbol for the mean is mu. For a sample, the symbol for the mean is x bar, which is x with that little bar over it, or m. Also, typically for a population, we use capital N to represent that it's actually the number of values we have. Whereas for a sample, we typically use lowercase n to represent the number of values we actually have. Okay. There'll be an exception to this rule we'll get to later. That's why I'm saying typically. But for now, just hold on to that. Okay. It just seems that no matter what I do, I'm always just average, says the mu sitting there on the couch. So that funny looking mu, remember, is always a mu, and that is our population average. Okay, so weird stuff going on in this picture. I don't know why these bottles are floating in midair. I don't know why these pills are just lying all around here. But anyhow, like I said, I've seen this picture too many times. But important thing to remember here is mu, population average, population mean. Okay. Okay. All right, so now what we're going to talk about is the median. Now, the median is simply the middle number. That's all it is. Just like a median trip in the highway is the middle of the highway, median number is just your middle number. So what you do is you take your scores, right? This is the same group of scores we've been playing with. We arrange it in order from smallest to largest. And we take the middle one. Well, the only issue is, what if it's an even number of scores? Well, then the median is halfway between, or the average of, the two middle scores. So one way to find the median, and it's not my favorite way, but this works, is to line up all the scores from lowest to highest. Figure out how many scores there are to the middle score by adding 1 to the number of scores and dividing by 2. Then you count up to the middle score or scores. Personally, I'm never going to give you 100 scores that you have to do a median on, so you don't have to do it that way. The way I like to do it is just go ahead, line up my numbers from smallest to largest, and then start checking them off, like 5 and 10. Okay, that's not it. 5 and 9. 5 and 9. 6 and 8. 6 and 8. And then I'm left with the two middle ones, 6 and 7. I take the average of 6 and 7. 6 plus 7 is 13. Divided by 2 is 6.5. That's my median. And as it says here, like I said, the median is 6.5. Now you might be wondering, do I have to do the rounding rule with the median? Generally, that's how we'll approach it in this class, but I won't fault you if you don't use the rounding rule with the median. You're mainly going to use it. We're not going to use the median a whole bunch in this class. If you took some advanced statistical classes, you probably would come across it a little more there. But we're not going to use it a whole bunch here. So you know you do not have to, but you can go ahead and apply the rounding rule to the median. Mode. Mode is the most common value in a distribution. It's the usual way of describing the representative value for a nominal variable, and it's rarely used with numerical variables. So for this group of scores, again, this time we have 5, 5, 5, 5, 6, 6, 6, 7, 8, 8, 9, 10. What's the mode? What's our most common value? And it is 5. It's 5 because we have 4 5s and we have less of all the other numbers. How about for the next group of scores, which is 5, 5, 5, 6, 6, 6, 7, 8, 8, 9, 9, 10. Well, for this one, we have 3 5s and 3 6s. What are we going to do? Well, the mode here is 5 and 6. You can have as many modes as is appropriate for your data. Okay? So had it been 5, 5, 5, 6, 6, 6, 7, 8, 8, 9, 9, 9, 10, then it would have been 5, 6, and 9. Okay. Now, here again, we have an example where you can take some time to figure out the answer and then come back to the video. I recommend that. We have 8 grocery stores that sell the PR Energy Bar for the following prices. $1.09, $1.29, $1.29, $1.35, $1.39, $1.49, $1.59, $1.79. And I ask that you find the mean, median, and mode for these prices. So remember the rounding rule, particularly for the mean. Go ahead and figure out these answers. And I'll be back in a second. Okay, so here we go. The mean. You would take the numbers, add them up, see that there are 8 numbers, so you divide by 8, and our mean equals 1.410. Now, why is that the case? Why did I add a 0, even though that's kind of nonsensical when we're talking about dollars and cents? Because I was following the rounding rule. There were 2 decimals in all of these numbers. So I added 1 to that and gave 3 decimals, right? So even though the answer came out to 141 even, I added that extra 0. Now, one question that often comes up with the rounding rule is, what do I do if some numbers are 2 decimals and some numbers are 3 decimals and it's mixed up like that? So I have 2 answers for you. First answer is, I'm not going to do that to you in this class. But the second answer is, what I would do is go ahead and go with the largest number of decimals. So if you have some that are 2 decimals and some that are 3 decimals, you would look at the 3 decimals and then round to 4, one more. All right, okay. Let's look at the median. To find the median, we first sort the data in ascending order. We see that there are 2 middle values based on this, right? 135 and 139. So the median lies halfway between. So we add $1.35 and $1.39, divide by 2, we get 137. Again, we could add the 0 here. We're not obligated to follow that rounding rule for this one. Okay. On to the mode. The mode is $1.29 because this price occurs more than any other price. And I will go back up here so you can see that the $1.29 occurs twice. Every other single price occurs only once. Okay. Okay. Sorry, we seem to have that twice. That's all I have for you today. If you have any questions, please feel free to attend the lecture that will be answering questions on this topic, and or set up an office hour time with me. Other than that, have a wonderful day. Goodbye.